everyone in between. Because if you were rocking with me, you're either friends or family. Promise that. Today, we are doing some more game stuff. We're gonna be doing some GUI, I think. Maybe try to get a system in place for our items. Let's go ahead and let me go plug my stuff. Okay, there's that one. Okay. There. Okay. Woohoo! Let's get active. Really quickly. So, we left off last time. Last time we left off, we were actually working on getting a nice UI set up, and that's fun and good, and all that stuff is nice. So that was what we worked on last time. Now, if I were to go ahead and just do a zig build run here, you can see we still have our select level options and exit. It's all nice and well. But if I press C, you can see that I have a sort of a background thing. I wonder. Hold on. Okay, that's a bug. But you can see we have a system that can accurately render and like press escape and press C, and that will automatically get our that'll get our stuff going. So press C, we can type in our stuff. Local X equals 100, local Y equals 500, player.teleport X plus Y, right, something like that. That teleports us correctly, and then we can get out of that. Boom. So what we did is to make that, we have a new window system in place. Let me show you that really quickly. We have this window system in place that basically has an allocator for allocating having the allocator that allocated the object, the size, the alignments, the window name, and then the pointer. And so what that does is this creates a pseudo interface. This is a zig way of doing an interface where we create a struct. And then once we're done with it, we can kind of just free up the wrapper and stuff when we're done. And so what we can actually do with that, so if I actually show you this now, if I can stop pressing random buttons, if I go to my world scene, my world scene, if I go down here, you can see we have a sort of is window open, set active window, and destroy active window. And so in our event settings, we say, hey, are we pressing the C key? And if we are, and if our window's open, we'll just destroy this active window. So if there is a window open and we press the C key, so if there's a code editor window open, we'll destroy that window. And then otherwise, we're going to create this window by going to our allocator and saying, hey, can you create this cool little code editor window for me? And then we're going to default initialize it with no data or anything. Because inside of it, you'll see if we go to here, we have a few things. We have our input buffer, and that's pretty much it for data. And then we set the active window. And what that does is now, when it renders, it'll say, hey, do we have a window open? If so, update the window. Do we have a window open here in draw? If so, draw the window. And so for context in our code editor window, we have this wrapping around I'm GUI. And so now with I'm GUI, we can say, hey, I want this put in the middle. And I want it to be I want this to be half the window size. And then I want it to be called code editor with these flags. And then we're going to, we have a thin wrapper around I'm GUI that sort of has a similar API, except we can specify a height scaler and a width scaler. And so if we go in here, you can see this has a few things, like we can load our fonts that we want to use, which in our example, we can't really scale right now with what we have via Jock. We can't really scale things correctly. We can't really scale like this menu font up and down. It's just because the font that it gives us is an opaque pointer, and we can't really modify that opaque pointer. So the preferred method anyway in I'm GUI is to just reload the fonts with the new size, and that's fine. So for our menu, we're gonna use 24 pixel, 24 pixel fonts, and then 16 pixel font here. And this results in a pretty okay looking UI, all things considered. It's very simple, but we plan on working on that today with an options menu and an exit works. And if I click select level, we have this back here. So what I actually want to do is want to start rendering maybe like health and stuff. But what that also means is we also have to work on ECS. I have my little notebook here, and in my notebook, I have a few things. I went ahead and wrote down some notes. I went ahead and wrote down some notes to kind of make sure that this bunch of notes about the senior capstone, about my project. Namely, I want to kind of allow the user to do a few things. I kind of started I was looking into like split screen gameplay. Like I told myself to look into that. I also had some things about top down gameplay versus like maybe like look into platformers. So like we're gonna look into different ways of rendering this scene. Right now it's just a top down kind of view, and that's fine. Oh, it's sort of top down, kind of isometric, but realistically it's top down. So in that, we're gonna try to keep with this pace at least, or keep with this theme, not pace. And with this theme, we're going to try to match that in terms of UI. This top-down aesthetic. It's also pixelated. I think it's obvious. So in terms of our pixelation, we're gonna do that there, and then maybe try to, if we get enough time. I only have about an hour to spare, but if we have enough time, I'm gonna maybe try to look into these gameplay ideas. Realistically, I need to make it where when I full screen this, things get centered. Because right now when I render things, it's not like when I full screen it, it's not properly shifted. So there are a few ways we can do that, and then we're gonna explore those today as well. So, but the first thing that we're gonna do is just UI. So what I want to try to do is get a little list box rendered of items maybe. So let's go ahead and go to our character and let's edit anyway. I want to go ahead and maybe do. I'm gonna do an ECS, which maybe means that we should try to convert some of this stuff to ECS. I want to stay on track. I have goals in mind, and I know I said UI, and I am planning on doing UI, but we also said we're gonna work on a world system, and in our world system we have entities, and entities sort of need to be rendered. And so I think it makes sense for us to also just approach our, go ahead and approach ECS. So let's basically do that. Well, we have Zig ECS already installed. Zig ECS is already integrated. Now we can just kind of import it, I think. So if I do cons ECS equals @import ECS, it should, yeah, so it automatically links that. So we have this stuff. So we can see entity, dispatcher, utils. Let me go ahead and look as Zig ECS. We have a couple examples here. We're going to go ahead and look at these really quickly. So let's go ahead and switch over. Switch over to our browser. And so here we have a registry. So that's what the first thing we do is initialize a registry, and then we can create an entity using this reg.create, and then we're going to reg add or replace with empty, which is just an empty struct. So let's go simple. Yeah, so reg.create, which is entity one, add these components. Same thing here. And then we're going to create a view where we iterate through those, get that stuff, print that stuff. And yeah, so let's go ahead and just get on that. I think it's better to start writing code and stop reading code. So the first thing we want to do is we want to create a registry here. We can kind of get rid of this for now. We're going to actually say registry, ECS.registry. And so in here, we'll say .registry equals ECS.registry.init. And then our allocator we're going to use is just going to be our context. I'm very glad that Jock has a global allocator that we or not global, but the context allocator, which I don't know what it uses under the hoods. I don't quite remember what it uses under the hood, but it does have something. I would assume C allocator by default, but I don't know. So now we have a registry. So what can we do with this? Well, I think the first thing we want to do, we should probably move this, but I think we're gonna have an add function on this, maybe like add entity, and then or create maybe we have self.character, and that's fine. But realistically, a character is going to have an entity tied to it as well. So I guess we're going to create that entity, which they will be entity 0 by default. And then they're entity 0. And so I guess when we just initialize the character, maybe we don't even maybe we just ignore the fact that character exists here. And so what if we do self dot registry dots? Okay. So it's just basic view. That's any component. I guess we have like an update component that we would use. I don't know specifically. If we go back to this implementation, let me actually zoom in really quickly. Oh, entity traits. ECS.entity traits. I don't know what this is. We can look into it. ECS entity. Okay. Oh, okay. So it's basically how big these definitions are. So like this is stored with a U32, this is indexed with a U20, and then versioned with a U12. And this is the large one is U64, U32, U32. Okay. That all makes sense. Now there is an actor that can maintain its own registry. Oh, actually no, it has a pointer to a registry. Okay, so we can create an actor. Okay, that actually might be. We might just use actor there. Yeah, we might just use actor there. I think it makes sense to try and attach, rather than trying to make like a little entity for everything. Just use this actor so it can hold its own thing and then hold its own entity. Now, do we know what the best way to iterate over, or for the system to update them, like to actually like iterate and update this if they have like an update or draw on them? Because we need some way to when we create the actor to have a registry that maintains a draw and update. Do we know the best way to do that? I don't. Okay, we can look. Non-owning group iterate view. These all make, yeah. But I don't. Maybe there's some tests here that we can look at. Okay, this is just okay. I do the same thing in mine, so I can't complain. Okay, there's a caching system. Okay, that's cool. I like that they have a cache built in. Process. Okay. Maybe it's the process we want. Maybe we want a scheduler. Maybe. So let's try to read this code. I understand the support of ENTT and so many games have been made with ENTT or NT NTT. That's called entity NTT. um, there's a signal. There's a signal thing with like a dispatcher, which signals are nice to have because then we can like listen for changes to that. And oh, but I wouldn't. I was hoping there'd be some. Okay, so we have two structs to work with. Create the registry, add the create the entity, add these components, and then iterate over these views. Um, but what if we don't? Maybe I just don't want an ECS. Is what I'm complaining about. I want an ECS. So ENTT draw a update function. I don't know. No, I don't really care. I don't. I'm. It may be best to look at ENTT to see it better because this is like really a lot. But I've never properly used an entity component system for a game. And I know ECSs are nice to have for a number of reasons. Okay, so there's a renderable, and that may be what we're kind of searching for. And it's gonna be a little bit different with Zig, obviously, but kind of. Okay, they have a context with in place, but I was hoping that maybe they definitely have examples, right? Yeah, because I know obviously Mojang is one of the biggest users of ENTT. Um, okay, so we're iterating over all the entities that have positions and velocities. Is that correct? No, because this is. But what if they don't have a? What if they don't have a this? Oh, this is a view. Duh. Okay, it's a view. View will only grab the ones that have position and velocity. Now, I don't. I wish there was some more. Um, I wish there's some more like examples, and specifically, I wish they had more examples of how I would want to use that because I'm not really too familiar. Um, I just I want ECS. I know I want an ECS. It's just okay. This obviously makes sense, but what if I have a sort of draw function? Okay, here's maybe. Um. Oh, I guess we are saying. Oh. Okay. Right, because for our updating system at least, we're saying that. Let's see. So they create a position and velocity. They have a registry. They create the entity. They add this component with whatever I is. Like they're basically just forwarding I, which is like setting like I guess it's like 0, 0, 0, 0, 0, 0, 1, 0, 2, etc., etc., etc. Or no, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc. And then adding a velocity to this if it's an even number. That's cool. Then from there, they're going to create a view. This view gets the position as a read-only copy, and then a velocity, and then it's iterating over each and saying, okay, so saying for each of these entities, we're going to get the stuff and then do whatever. And then for the game, we're going to get the registry, and then we're gonna, so for the game, we're going to create the registry. We're going to have a registry here. And then here's a new system. I don't know the best way to integrate a system with well, we're using the Zig equivalent of ENTT, but I don't know how a system looks in this. Like, it's supposed to be a port, and so I'm not familiar with how ENTT works. I think it's called NTT. That's my assumption, is it's NTT. And so we have a sprite system that has a view. Okay, so we have a sprite component. So we pass in the registry. We get the sprite component. We get the transform component, and then iterate over that, and then wherever the sprite is the sprite is set to wherever the position of, or the destination is set to wherever the transform pos x and y is. Okay, cool. And finally, the main function. So for example, this creates a bird. We're going to add a sprite component with these layouts. So it's going to give us the entity, and then add the, what's this sprite component has, I don't remember, but we have this definition of this rectangle with this rectangle, and then this texture, and then add this transform component, and then a key input component. Oh, okay, and then two more, and then we read input, update, and then render. I'm curious, what does this look like in terms of like actual? So we have a sprite component, we have a transform component, a key inputs component. They have a system that updates and renders. So, oh, okay. So we take our systems, we pass the registry, and the registry will do whatever it wants to it. Obviously. Okay. Or I suppose I could even make a wrapper, but I think it's just better to just call each system individually. So we can refactor this, and so the movement system, if it has a key input component, we're gonna get the transform and the key input. And so in terms of the Zig version of this, we're gonna do a similar thing. So we're gonna have a, let's have so we need to have a list of systems. So what systems do we want? We want a velocity system, a position system, and a render, and I guess a sprite system. That would be fine. So a sprite system, it's just gonna be whatever, because they don't have a system thing in here. It's like whatever you want. So I could just make a struct. Let me make a new folder. I don't know how to use this to make a new folder. I forget. There's a specific uh there's a specific binding I can use. I don't know. Let me switch back over to my thing. Let me look up something really quickly. Um Control E. Control E. That's not working. Nope, that's also not it. That's still not it. Or is it just in here? No, that's just. Or is it maybe leader E? No. Leader. Leader. I don't know. This is what I'm using, right? I'm using Interim Telescope. We're gonna look for this. New. tab. I want to make a new file though. Telescope. New file. Little F. Uh oh, in insert mode. Leader. So AC. Oh, it's leader C. Okay, so we'll say systems, I guess. Or let's say world slash systems. Haha, that makes sense. And then oh, this needs to be leader C. This needs to be systems. Thank you. And we're actually gonna. Can I like move things? Can I move this? Move? I can. Wait, what do you mean? What do you mean I can't move things? Okay, whatever, whatever. Telescope. Telescope move. Invim, telescope, invim, telescope, move file. It's a good to have this now. I don't remember it. Oil invim. Oh, okay, I see. I see. World. That's it. Actually, I would disagree. I actually do have a selection here. Selection being moved. I laughed. So everything except like move works. How do I do this? World.zig and then is that not selected? Am I stupid? Let me look this up. A tab? Uh, oh, I see how it works. Okay, so I select that tab and then paste in. No. What? Um. Oh, Alt M. Tab. That work? It did not. You can okay, and then press Alt M or just M and tab. I'm locked in. I need to be locked in. Ah, I'm now locked in. Promise. Okay. Okay. By the way, that's Mr. Wichita State Shocker. If you're curious, that's Mr. Wichita State Shocker. I got him at a dollar store for $1. He's a little messed up, but he's cool. He's cool. So let's implement our systems. So we're gonna say, um, we'll do a sprite system. And so now we need to import jock. So let's do standard first, or standard. And then we're gonna import jock. Always gonna import jock. And then we're gonna import ECS. And then now we can say registry is going to be, or the pub function draw the const self equals this, and then pub function draw is going to be, or just update, I guess, and then self, and then our registry will be our registry. Okay, so yeah, we need a update, and then registry is going to be ECS.registry, and so this will probably error out, I would assume, and then we'll say we do need a list of like we store. No, it's probably not smart to store reference to the world. We could pass it as a thing if we wanted to, I suppose, but it's fine. And then pub function draw, and then self, and then we would do. Oh wait, shoot. Let me do registry dot var view equals registry dot view. And I guess we need to go into our components. So we need to go into here, and we'll go to and then we'll do another create here, and we'll say position zig, and this position will just be notifications. We'll say x, which will be a float 32. We actually could, we can actually specify type, I guess. We'll say data type equals f32, and then x data type, y data type. I say float type. Float type, and then we'll say pub function. I think we set to 0.0 by default, I suppose. 0.0, 0.0, and then we can say pub function int. So we need self, by the way. We need to const self equals this. Oh, actually, let's put it above this. Const self equals this, and then we're going to go ahead and say pub function int as int. We'll say comp time t type. Type, and then void, not void. We'll say that's fine. This is a component. This is just a component we have. We can do an add-on if we want to. So say self x float type, y float type, or actually we can just say like other self, and we just make a new one. Or no, let's modify this one. So let's do so say return or say self dot x plus equals other dot x self dot y plus equals other dot y. Return self. And we'll do sub minus minus. That should be fine for now. Just a plus and minus, and then is want this. We want the component, so we'll say const. Oh, what we can do is do in our world make a new file called components.zig, and there's say like pub const position equals at import components slash position.zig. So now in our systems, we'll say const components equals import dot slash components.zig. And then this will just be a components position, which is good. And then for no, it's const view, right? And then this is a dot, yeah. And then const var iterator equals view dot iterator entity iterator for iterator dot next entity, or it's gonna be y actually, while entity. And we will say we don't have a list of sprites though, so we do need to maintain a list of sprites here. Do we? Would I? Hold on. If I wanted a sprite system with a draw, what's the best way to do that when adding one? I guess it would be like we attach a list of sprites, and that would come from like jock dot I need jock2d, const j2d, jock dot j2d. It's gonna be j2d. That's sprite, and this would be an array list, and then we need an initialization function here with an alley. Standard out the allocator. And then we say return sprites equals standard array list jg.sprite. I think it's discouraged to use this managed one because of some like passing around of like things, but this will be fine for now. Self void, and this will have we're gonna say return self.sprites.dnet. And so then we'll go ahead and say sprites, or there should be a position, isn't it? Okay, self.sprites. How would we attach, like what, how do we make sure that I guess we could do like a sprite iterator equals sprites dot, isn't there a self dot sprites dot iterator or something? This doesn't have this doesn't have an iterator. Oh gosh. The writer, no iterator. That's okay. So I guess what we can do instead, is maybe keep an index for now. Usize equals 0, and then const sprite equals self sprites dot items index, and then we say sprite dot. Oh, this doesn't have a position thing on it. I forget about that. Let me look in my character and see how I do this. So I render. Let's see. I drop by saying batch.sprite. Ah, so I need to patch the batch to it. That means like I would need to do that in like. Okay, that's okay. Probably also worth to make a systems.zig. And then it's gonna have const sprite system goes import systems slash sprite system.zig. And then say const systems equals import world systems.zig. And then our systems would say like position system. That would say systems.position system. Or I guess it'd be like translation system, maybe a little bit better name of that. Translation system. Um, can I copy this? Let's see. Y. Y is the system of copy, so tab. Y. And then that's gonna be position or translation system. And then this will just be, they won't have a draw, it'll just have an update. And then this will not have any data on it. It is just a translation system where you're gonna have a list of what's it called? Forgot the name of it. Where you're just gonna have a registry. I guess we could like attach a gravity to this or something. We don't need jock or this. We just need, realistically, we don't need any of this. We don't even need like an initialization system. I guess we can have like a gravity, and then that'd be like a float there too, and then we can, or I guess no, it'd be not gravity. What's that called? Friction, and I'd say like F32 equals 0.9 or something. Um, or actually here, let me do something. Let me instead of calling it translation, let's call it and transform system. Yeah, and then we'll go to our worlds and call this transform system, and then transform system, and then we'll go into our systems here, transform system equals import systems slash transform system. Awesome. That system is literally just like we're just gonna have like a velocity. We're gonna get like a velocity and position and just like modify that position by that velocity. So let's go ahead and copy this. Say velocity. So now in our transform system, we can say, where's it at? Where's our transform system? We'll say this is components dot position and this is components dot velocity. Components dot sig, and we'll say velocity. These are just the easiest ones to implement. But this will be how we manage our like our inventories and stuff too. So we need to have a space to set up. I was at 7:45. I have about 15 minutes left. I just want to see if I can maybe get this rendering. So we'll say it is an entity. Entity. Right? Is that how I use this? Let me make sure. Let me go check this. Get const. Oh, duh. Okay. So we're basically gonna say view.get. So const position equals view.get const position components dot position. And that'll be on the entity. Oh, actually, no, this is a var. And this will be just a get. And then this will be a const. And that's what because velocity doesn't change. This will. Oh. Okay. So now let's say position dot x plus equals velocity dot x. And we'll just discard that for now. And then we could then, oh, and I guess, well, I guess if we did like a var velocity here and a get here, and then do our velocity dot x times equals velocity times equals self dot friction, and the same thing here. But the best way to render this, let's see the character thing. Because we have the position that we do when we draw this is we take a batch, we take our camera pause, our scale. So now what we can do actually in our sprites, where's our world, our sprite system is actually going to ask for the camera pause. And that'll just be, we can just say it's a rectangle, I guess. And then our scale. Let's actually ask for the registry first as a first thing. Makes more sense to ask for that first, and then rectangle, and then scale at 32. And then we'll say var view equals ECS dot registry dot view, and that'll say components dot position, and then for view dot, oh wait, hold on, that's a constant actually, const. And then var iterator equals view dot iterator, and then we say for while iterator dot next entity, And we don't really need to update this here, do we? We just need to draw it realistically. Yeah, so we don't need an update system here. But now we can say index 0 and then index plus equals 1, and then we'll say take this and then we'll say pause. We'll say our position is going to be the view dot get const components dot position, and then on the entity, and then this will be oh, and that should maybe actually we should maybe just return a copy there. Return dot slash dot x equals self minus x, somewhere minus x, and then dot y is gonna be self dot y minus other dot y. So we're just gonna turn copies here. It makes like, yeah, there's like some point where we could say, hey, what if you just want to modify it and yada this, yada that, but it's fine. In this case, it doesn't make sense for us. Now what we're doing is we're saying, oh, but we need actually. Oh wait, hold on. We actually need to say dot x equals position dot x minus camera pause dot x, and then dot y equals position dot y minus camera pause dot y. That's a point, what that is. And that should be fine. And so then actually we don't really, and the scale multiplier is also a point. So we're just gonna say x equals, I guess we could also do a scalar, but like we're just gonna yeah, I guess we'll do a scale. Just try to keep consistency. Components. We'll copy this and we'll just call it scale. And it's just gonna be a scalar. Or value, I guess. Oh, actually, you know what I could do? Instead of making files for that one, I can just integrate that into that. It's just so simple that it doesn't make sense to have a new file for it. Scale, like that. And then in our components, we'll say pub const scale equals struct. It might not even make sense to do value float type equals 1.0. It might not even make sense to do separate files for the components in either. So let's move these. Let's move these all back in here. Source world components, and then we will just do structs here. And then the float type, we get const float type equals f32. And then we can just like that. Same thing for velocity. Simplification. There's no reason to keep it simple, stupid. Keep it simple, stupid. And so that's gonna actually get rid us of this entire thing. Probably need to do a git keep in that, but that's fine for now. And so now in our systems, in our sprite system, we actually grab our components dot scale, and we can say scale, and then this will be scale that value dot y equals scale that value, and we could probably make that something else other way. What does the override? What? What? What are you yelling about? That doesn't override that. I have no idea why it's yelling about that. It seems not right, actually. Um, and then now we can integrate the system into the world. And so for us, that means we have a sprite system as well. Sprite system. I think I already have this in. I do. Oh, but they're not public. Silly, silly me. So that's that. And then in our world, so now we can say self dot transform system dot update with our registry. I guess we'll pass the pointer to it. And then same thing with our. Oh, we don't have to do it actually. Our draw. That's fine. That we'll keep that. But then we'll say self dot sprite system dot draw, and the batch will be B camera pause will be camera and scale to scale. And we'll try that. There you go. I'm missing the registry. Self dot registry. Oh wait, right? Batch. Wait, what? No, that's incorrect. The sun is nearly gone. Lights are turning on. Great song. If you haven't seen La La Land, it's a hell of a song. Um, registry, badge, camera, scale. Um, and then our update system, just registry. Everything is in its place. And then we maybe should. You know what we'll do for this? Actually, we're gonna separate. It doesn't make sense. Actually, it doesn't make sense. Separate that up for now. But what we can now do is because we create our character in main. Oh, it's in our main menu scene. That's right. Oh wait, no, it's in our state. Oh, that, and then we'll say so. Then we'll go var actor equals world dot. Oh, world slash world. Good to know. Can I create an actor? Actor. Uh, I guess it's gonna make an entity and then const entity. And so then we're going to attach this like so. Um, so we'll attach this like so. We'll say entity. Ignore this. Speed will be good, I guess. But that'll be the velocity component. So we can sort of define velocity or speed for now like this. And then it'll be a little bit difficult. Oh, because this is a whole sprite sheet. Oh, that's a slight issue. Oh gosh. Oh, you make it hard on me. So we're going to we're just gonna nuke this for now, I suppose. Um Maybe not the whole thing. Bounding box, key down, key up. Yeah, which I do need to get rid of these things, but the draw needs to go. We have an entity now, so if we go to const ECS equals import zig or ECS, and then instead of a point here, we'll say ECS, and we'll say, oh no, say entity, ECS.entity, and then we'll say entity, which I think it's just a number, isn't it? Yeah, just a number. Is this the 50 Shades of Grey thing? No. It's kind of. Oh, you know what it sounds like? It sounds like a podcast thing, is what it sounds like. And then we'd say, I suppose we could pass the registry to this too. Like ECS.registry or something. Go back to our worlds. And then, oh no, no, it'd be in our main menu soon. Um, no, it's the world scene, not the main menu scene. And then, um, wait, what? What is? Wait, where is it? Where's your character initialized? Is it okay? It's in state, initialized in state. My goodness. And we'd say world dot registry. And then in our character init, we'd actually say registry dot add. Yeah. So say entity, and we'll say we need to wait. Hold on. Do we need to? Yes. I need to go grab my components. So this will be components equals import, and we'll say dot dot, or no, just be a world slash components dot zig. Awesome. And then so this will be components dot position, and I'll say dot x equals 200 dot y equals 200 for now. We'll go back and fix that. And then our velocity is going to be 0. And then can I register add all or something? Add all. Add types. It's no, yeah. We do one at a time, baby. And so then now on this we'd say scale. And then it's dot value equals, and then scale is like 2 or something. And so that's gonna do all of our stuff. Is this errorable? It's not. It's not errorable. So we'll go ahead and add these components, and then what do we do about this? What do we do about our sprite sheet? I suppose we could just like off. Let's sprite info. We could do like in our sprite system. Where is it? What's our system? Because it says sprites. What if we did like sprites or sprite sheet. But like at the same time, oh, I see. I see why I thought that. So scale times value. Let me check something really quickly. Um, scale. Um. Oh wait. Also, const sprite equals self dot sprites dot items index. I could do something like this is kind of a regression. That's kind of a regression, and that's fine. Actually, maybe I should be just fine with a regression thing for now, just so I can have an ECS in place and then build on top of it. So for this, in this case, we'll say what's our world? Um, world, and then we're gonna go to our. Oh no! We want to go to our character. So our character's gonna have all these things, and then we actually are gonna define. Or wait. No, we don't actually. But we are going to regression test this pretty much. So we'll go back to our state and then our character. So we're going to world.registry, add components to character entity. We need to do import our components. So we'll import our components. World/components.zig. That's fine. And then we would need to say what if we set it up inside of our worlds? So make a setup function or something, and then or I guess I could maybe also do something like we could say like const registry equals that, and then oh down here actually, and then we'd say registry that create character or worlds, and then we'd say, and then we'd actually go like something like or actually registry, and then we'd actually need to pull from our components. So and like I said, I know this is like a whole regression thing, and now it's like, but it's gonna be better in the long run once we get this done. And we don't need to pass that. We just need to pass the entity into this. And then we'd have to go like, oh, but we have to initialize the systems. So we'd say like var sprite system equals systems dot sprite system dot init, and then it'd be context dot allocator or hunt. Yeah, it's context dot allocator. Not crazy. Then sprite system dot add, and then we'd say like character dot sprite or something. Function add. We can also even do a hash map in there, but I feel like that's just unnecessary, right? Feels necessary at least. So say self PHP.sprite, and then this would be self.sprites. Try self.sprites.append, right? This should be in line at least. So if I have like a pub function, create entity, and then like no, it's fine. That should kind of sync up anyway. Spawn pause dot x, and then spawn pause dot y, and then that should be fine. It's gonna cause a lot of issues, but let's see what the errors we get. Oh, source character .zig is not in there. That's correct. So it's gonna be in dot dot. Oh shoot, dot dot slash. And then where's the world one at? Is it just up to me to go figure it out? Not in character, is it? Certainly not. State maybe? Nope. Maybe it's the UI actually. Nope. What about? I thought it'd be in state, but it's not. Scenes? Nope. Also correct. I don't know what this would be actually. Block script's fine. Oh, is there a script system? Hold on. It's not a script system. Oh, and that's gonna break. Where is this? Where's our world? Maybe make sure I saved it or something, I guess. We are trying to like absolve this of any like. Where the heck is the world thing that's yelling about? Oh, main.zig. The world slash. The one thing I just didn't check was world.zig. That's hilarious, actually. Registry.create. Which that's in world. And registry.create. Oh, that seems to be bar. You're right. Bar. This is wrong. Root system okay. Components has no thing called components position. Oh, I know what happened. Hold on. What is it? Yup. Yep, that makes sense. What else? Transform. Oh wait, this. Oh yeah, we have to declare systems. So dot sprite system equals sprite system. and then dots transform system equals just be that. And then what else we have here? Oh, we need to try the registry. Okay, we need to try the okay. Yes. Try. Then in the sprite system, we get to go into our system here. Sprite system, and then this is errorable. I guess. Okay, so we have to kind of make sure that's. Oh no, expects one. Oh wait, hold on. No, expects one thing. It gets. Oh, duh. I should read the error actually. No. Oh. State.zig does not. You're right. State.zig does not have a reference to character anymore. And then what's the next one? Expected type ECS multiview 2 found const. Oh, because we need to go to our sprite system now. We'll get used to the system as we move on, but I think it's gonna be a little bit of a learning curve. And then the next one is going to be the same thing with our other one. So transform. I don't know why I assumed the view was constant. Suppose it doesn't make sense that way. Let's see what else we have. What's the other errors? No field name R. Oh. Incompatible types. Duh. That's in our sprite system. I think I am digging the idea of systems though. They seem really cool. Scale. Oh wait, I need. Oh wait. Scale. Entity scale, I guess. Let me say entity scale dots value. This will be entity scale. This should probably be named something like global scale or something like global scale, and then back here a little bit, and global scale here. No thing. Oh, world scene. Where's our world scene at? Character.pos. Ah. Um. So our character is just gonna be. So we'll say our var view equals self dot world dot registry dot view. We'll say components dot position, and then we'll import that right quickly. Const components equals import dot slash component world slash components dot sig w, and then the entity or the character is just gonna be entity 0. That's how that works. Oh, can we just do like a self.world.registry.get? We can. We need entity though. So it's the components.position. It should just be entity 0, realistically. I could store the entity ID. Doesn't self. Oh wait, the character also has a. Const position. Oh, I should also get const, by the way. Let's say position.x position, and we'll go delete 2 words. Boom. And then what else do we have here? No character. Oh, no velocity. No velocity. Duh. Now, boy, she'll chew you up. So all I need to do for this realistically is I have do I have the world that I'm in? I don't have the world. I can maybe pass the world I'm in. Just for like the time being. So like worlds, and then dot world equals world. And then this pointer. Now we can say in here we'll say const velocity. Yeah, const velocity equals self dot worlds dot registry dot gets const. Oh no, dot get. It's dot get, and then it's gonna be components dot velocity, and then it'll be on self density, and then it's gonna be that's. Oh, and then I need to do something with the other one. Hold on. Oh wait. Oopsie. There we go. Now, do I like fetching the velocity on every key press? No, absolutely not. We're gonna have to though, sort of. And it's not like it's gonna be a huge thing. If we maybe it's we're worry about cache hits or something, but that's fine. I actually can just remove this for now. We'll say old update or something. And then in here we go to our worlds. Yeah, that should be fine now, actually. But there should be might be some more errors. Yeah, there are. What else do we have here? Oh, right. We do need to. Where's our character? We get a pass. Oh, that's where that's okay. That's what's gonna be an issue is we don't have the pointer yet. So, how do we want to do this? I suppose we can do something like this, or let's copy this over like that, and then after we create the world, then we'll like something like that, I guess. And then all of this adds our character sprites to our system. There has to be a smoother way to do this, though. We'll figure that out, I guess. Oh wait, no, we still want to create the registry. My bad. My fault, gangy. And realistically, we can just kind of inline this actually. So let's do this, and then we're going to. I would love to have a better keybind for not throwing things into my register when I delete it, or like yeah, when I delete it. Where's our world initialization stuff? Say there is state main. Oh, sorry, excuse me. Wow. Apologize. I guess now we can say like yeah. I don't like doing this, but this what if we'll look at it later. We're not gonna try to get too intricate right now. And then we'll say world sprite system, and then we'll say world dot world dot, and then this needs to be a var so that we can and state is given the world. Right. Okay. Um and then character.inits. We need to import character, obviously. Character.zig. My fault gang. Character. Cool. Oh, then we didn't import our components. So let's do that really quickly. So cool. And then that's good. And then we'll go back to here, and this shouldn't just be like a pointer to a character, it should just be a character. I don't even use that much, so oh, and then now our character, because we still need to. Why are we passing the world again? Ah, for key down and key up. Right. Realistically, we could just have it as a system, like a key press system or something. But I suppose we can just go back. We'll fix that later. So say world, and then this will take. Right. Let's refine. I don't know that. Oh, you want the pointer to the world. I guess we could load this first, and then we can say in our state, we'll say like after this, we'll go back here, and then we'll go state.world. Um, state.world, and that gives us a pointer to the state rather than before. And then let's just stop. Let's stop assuming that the world is default, like it just doesn't exist, because we do have a world by default, which might change a lot of these errors, by the way. Oh, this will be state.world, 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 and then this will be like this. We're actually going to inline this so that we don't have to, like, to care about that extra variable. And so this will then be state.world, and we'll eventually move this back into this into the setup scene or something. But like to have this sort of thing done with. I just want to have some amount of. Oh, state.zig. Sure, because it's not null anymore. We assume that it does exist, which we should have. We will have a world. We'll probably convert it back to a thing in a little bit. That's it. Cool. Oh, world scene. Where is my scene? Main menu scene. Yeah, this is not null anymore. We're getting closer. We're getting closer. That's an optional type. This is true, I suppose. It does in fact exist. I guess I do need to say state.world character equals character. And then in our world scene, so go to our scene, world scene. Position. Cool. We're gonna assume that it exists. There was another error I didn't see there. What was it? Oh, velocity.y. Velocity. That's in character. Y equals. And actually, I can just sort of keep this in here for now. Equals 5.0. Oh, we should probably let's make below all this the non-optimal things just for cleanliness. Okay, let's see what we got here. We have a menu. Gravity hates us, so the friction thing is not working out. Oh, what am I not? Oh, oh yeah, that's right. Where is it? In our world, we need to make sure to discard the thing after we're done. Where's our dnet? So say self.registry.dnet. And then we'll do the same thing with self.spriteSystem.dnet. Should be all we need. Or let's deinitialize our sprite system and then our registry. Just so we clean up our systems before we clean up our registry. And then the last thing I want to do is I want to go into our transform system. And we're just gonna we're just actually gonna set this to 1.0. Okay. The motion is not as fluid as anymore, and also the scaling is kind of weird. I don't know what that issue is. What leaked? Oh, our character leaked. So we need to make sure that we deinitialize our character as well. Which I think in our world we just store. No, we don't. No, we do. So we'll say self.character. Or do we pass that to our state? I don't think we do. The only place that we create our character is in when we create our stuff. Yeah. And we never deinitialize it until so. Yeah. Okay. So we'll just put it in our world stuff then. So deinitialize our character and then our map. That's fine. That's fine. Now we've cleaned up everything. No, oh, the scaling was the issue I was looking. Yeah, so it cleans up correctly now. And then does I guess one question I had. Let me make sure I'm good on time. Okay, I'm very limited on time. Um, um, so we'll do one more thing. Okay? The last thing we're gonna do is we have our what am I looking for? The scale. Why is the scale so weird? What do we have set to in main or in this? What do we pass the global scale? I don't remember where we passed our global scale at. I passed it somewhere. Draw, and that's our world, and that's not our main that we draw that. No, it's our scene that we draw that. Duh. So in our scene, in our world scene, we pass. Okay, scale is passed like this, and scale is set to 2. So we can then just go to our scale then into our components. Go to our components. We can go to our scale. Oh, I think I initialized it in the character with 2. I did. Oh, let's see. So everything besides the animation should be back to normal, and that's fine. Oh, everything's going smoother now, by the way. Oh, sort of. Hold on. It's kind of weird. It's doing some weird input stuff. Sure. That's fine. But what if I? Oopsie. Um. Okay. So that's cool. We have now integrated. So it's like git add dot git commit and feed integrate ECS and utilize it in our world. Cool. So that works. Now, the only thing I don't like right now is this entity stuff, like the character stuff. But I'm not sure the best way I want to do that. So what is the best way to do that? Like ECS animation. Next, we have an animation system that someone wrote an article about this. Apparently, let's look. Or never. Well, I was going to look at it. Never mind. Because I go to my thing, my browser. You can see that we have that. Oh, I see. Looking at like an ECS entity system. I suppose we can have a sprite component and then a sprite system, and then allow our grab the and then allow us to change the like change the current sprite depending on where we press. Is sort of my takeaway from this. So it'd be I go to here, like in my character, we have a sprite system obviously, but then his sprite system is a list of sprites. Can I modify? I could potentially. I could potentially map. Oh my goodness! I could potentially have a hash map for our sprites, and then allow our entities to index into that. Basically, we can. Let's check something. So if I did in our so what if in our sprite system we have a get function get self and then we can say like entity ecs dot entity and then it returns or when we say updates self entity ecs dot entity sprite j2d dot sprite and so then we say const or var self dot sprites the items entity, or say as usize entity. Or I guess it'd be self dot sprites dot item equals sprite. Allows and that doesn't have any issues. I guess we can, well, I guess it'd be like self dot sprites dot replace range swap. Or I guess we could say if const index is going to be as usize entity, if index is greater than self dot sprites dot len, nothing, the items dot len, length, size, items dot len, I guess. If our index is greater than that, then we'll return error dot out of bounds or something. Let's say index like that. And so that's allow see allows, what was that? Okay. We'll say allows a switches a given entities sprites to the given to the past sprite. That's cool. Nice. And so, and then when we remove the sprite, what do we want to do in that case? Because sprites don't always exist. We'll think about that later. We just want to reintegrate our character animations. So we have the world, don't we? Self.world. We do. Sprite system set to update. So we can now update, so we can take our self.entity and pass okay. Technically we should just like you can set self dot sprites self dot sheet dot get sprite by name top or front like this. What else do we say? We'll say pump function gets sprite by direction self and then direction and that should return a sprite. And so we'll say return self dot sheet dot get sprite by name tag name. Oh, I guess it'd be say standard dot enums dot tag name direction self dot direction. And it's j2d dot sprites. Oh wait, hold on. I'm silly. We just have to actually just update it by doing self.sprite. That should just fix that. And we can do something a little bit. Oh, sure. Sync build run. No, I guess we do need to try that. Try. What's the last error? It's not update. So what's the thing then? I forgot the thing. Systems. Let's update. Like we should call it replace, by the way. Oh, I see. I see the issue. We can actually technically. I guess we bubble it up. That's fine. And that's gonna be. Where's our key down stuff? It's in our key down. A little hacky, but it works. Aha! Animations are back. Cool. Commit M fix. Re add animation or animations. Oh, you're right. Sorry. Cool. And that's the last thing we need to do. So we'll get out of here. Thank you all for coming out. I know it's been a little bit, and today was a bit more of a laid back stream, but always appreciate you guys coming out and hanging. We'll work on this more later, but we have a nice ECS now built in, which is nice. It wasn't what I expected to do today. I had a lot of things written down, but we do need to work on ECS, so glad we have that integrated. Okay, well, everyone.